mole concept and molar mass. Let us discuss about the mole. Mole is represented by N, and that is nothing but weight by molecular weight. And you've got another equation, that is number of molecules. It can be represented as N dash. So number of molecules, that is N dash or N prime, is number of moles into Avogadro's number. Okay. And this N can be replaced as W by M. So W by M into N, where W stands for the mass or the weight, then M molar mass or molecular weight, molecular mass. N Avogadro's number, that is given as 6.02 into 10 power 23. A number of particles or atoms or ions or anything, it can be just a number but per mole. Okay. And you should know about the number of atoms also. So number of atoms, this can be safely represented as N double prime, and that is also N into N, but in this case N represents weight by atomic weight, so into N. So this is the simple formula to determine the number of atoms. This is number of molecules. This is number of moles. Okay. So based on that, let us work out some important problems also. Take down. Calculate. Calculate the number of moles of 7.85 gram iron. So the number of moles N is asked. Given weight, that is 7.85 gram, and the element here is Fe. Therefore, in this case, since it is an atom, you have to introduce the atomic mass, is it not? So what is the atomic mass of iron? The atomic mass of iron is 56. 55.8, you can put 56. Therefore, N is equal to, what is the formula? W by A, okay, right? So instead of molar mass, I have put atomic mass. Therefore, what is the weight? 7.85. What is A? Atomic mass 56. So what is the value? Can you tell me? 7.85 divided by 56. So 0.141. So this is the number of moles of atom. Got it? Okay. So shall we work out similarly another problem? Calculate the number of moles of 65.6 microgram of carbon. So in this case, atomic mass of carbon is how much? 12. Is it not? And this is the carbon, and its weight is given as 65.6 microgram. It means 65.6 Micro means 10 power minus 6 such gram. Okay. Now you can employ this formula. Therefore, N is equal to what is the weight? 65.6 into 10 power minus 6 gram divided by what is the atomic mass of carbon? 12. Now get the answer. Yes, very good. So 5.47 into 10 power minus 6 mole, right? Okay, good. Now let us move to, we need to calculate the number of atoms now. Okay. So we were discussing about number of molecules or number of atoms. Let me take up one of the, another question. Calculate the weight, number of moles of water of 360 ml. So in that case, the specific gravity or the density of water is 1. So 360 ml is equal to 360 gram, right? Being water. Because the specific gravity is 1, that is the density of water is 1 in this case. So you can replace this as 360 gram. Now what is asked? Number of molecules. So number of molecules of water, that is given as weight by molecular weight. Why you have put molecular weight here? Because it is asked as molecule. Okay. And what is the molecular weight of water? That is 16 plus 2, 18 gram per mole, right? Therefore, number of molecules of water is equal to, what is the weight? 360 gram divided by 18. So this is gram and this is gram per mole. Therefore, this is 20. So N is equal to 20. The mole inverse becomes mole. So N is equal to 20 mole. That is 20 molecules. Okay. 20 mole of molecules, or simply you can call it mole. Now, let us calculate the number of molecules. Mole is different from molecule. Okay. So for which formula should be used? To determine the number of molecules, you have to use N into capital N, Avogadro's number. So in the first attempt, we are calculating the number of moles, and here it is also asked number of molecules, N dash. So how to find out the N dash? So here you have got already N. So N dash is equal to 20 into Avogadro's number, 6.02 into 10 power 23. So this is 20 mole into, what about this? This is per mole. So they get cancelled so that you are able to get the number. Got it? Therefore, N dash is equal to how much? 0, 4, 0, 12. So 120.40 into 10 power 23. So it means 1.204. You can take this into 10 power 25. Got it? So this is the number of molecules. Please note down. This is number of molecules. Okay. What about this one? This is merely number of moles. Right. Now let us go one step ahead. I want to calculate the number of oxygen atoms present in this. So how we can proceed? We have to introduce here the atomicity. What do you mean by atomicity? That is number of atoms present in a molecular formula. Is it not? For example, H2O. This is the atomicity of hydrogen. What about oxygen? Atomicity of oxygen is 1. Okay. So now we can calculate the number of atoms based on molecules. So what is the formula for number of molecules? N into capital N. Now I want to calculate from this. Okay. You can introduce A here. Don't mistake that this is sodium, or otherwise let me eliminate. Let me put A into N into N. This is the number of atoms. So we can make use of this formula also, where A represents what? Atomicity, right? And what about this N? That is number of moles, okay? And what about N? N is number of, that is Avogadro's number. Avogadro's number, right? Now I can introduce another formula for this N double dash, because N dash, that is number of molecules, is N into N, right? Therefore, N double dash is nothing but N dash into atomicity, right? Okay, got it? So we have already arrived at the number of what? The molecules, where here, how much? 1 point. So we can make use of this straight away. Therefore, N dash is equal to, what is N dash? 1.204 into 10 power 25. So 25, right? This is N dash. And what about the atomicity? Atomicity of water, I mean oxygen in water. So let me consider as what? Oxygen. So we can calculate step by step. Now listen to me. What is the atomicity of oxygen? 1. So I am calculating the number of atoms of oxygen in water. Do you understand? Are you following me? So that is equal to, listen to me carefully, that is equal to, that is 1.204 into 10 power 25 into, what is the atomicity of oxygen here? It is 1. So you can simply put 1. So this reflects the number of molecules itself, right? Therefore, number of atoms of oxygen in water is equal to 1.204 into 10 power 25. That's it. So this is regarding the oxygen atoms. Now let me calculate the hydrogen atoms. So how many atoms of hydrogen are present in, that is 360 ml of water. Okay. So in that case, we can make use of this. So N dash is equal to, what is the N dash? That is already given as 1.204 into 10 power 25 into, what is atomicity? Atomicity of what? Hydrogen in water molecule is 2. So you can multiply by 2. Do you understand this? Right? So therefore, that is equal to, now you can put 2 4s are 8, 40 and 2.408 into 10 power 25. So this is the number of hydrogen atoms present in what? That is 360 ml of water. That is 360 gram of water. Do you understand this? Okay. So this is also a very good strategy. And they can simply ask, how many atoms are present in 360 gram of water? In that case, what you're supposed to do, you can add these two, because you've got 2 hydrogen and 1 oxygen. Now tell me, what is the atomicity of water? If it is asked, you can straight away add 2 plus 1, that is 3. So this is the atomicity of water. Water means it has got 2 atoms of hydrogen and 1 atom of oxygen, totally 3. So you can say this is 3. Atomicity of water molecule, that is in this case, is 3. So what you are supposed to find out, that is N dash, N double dash of what? Water, atoms present in water. How much? This is 1.204 into 10 power, what is that? 25. Okay, right? Into, into atomicity. Atomicity is 3. So multiply by 3. That's all. So 3 fours are 12 and you have got 3.612 into 10 power 25. Okay. Now let me summarize. So in 360 ml of water, that contains a 360 gram of water only. Okay. So it contains how many number of moles? The number of moles is equal to, what is that? That is 20 mole, right? You can write 20. Okay. And what is the next equation? Second, I have asked the number of molecules. Next. So number of molecules means n dash of H2O. Okay. Number of molecules of oxygen. I mean water. So how much? The number of molecules is equal to how much? N dash is where we are written here. Is it not? That is 1.201. 1.204, right? So 1.204 into 10 power 25, how much? Molecules. You have to say molecules, not mole, molecules, okay? Because we are discussing the number of molecules. And as a third case, what is that? Number of atoms of double prime, that indicates atom. So number of atoms of oxygen present in 360 ml of water. So what is that? That is that we already given oxygen. The same 1.204 into 10 power 25 oxygen atoms, right? Okay. Then 4, that is N double dash of hydrogen. So how many hydrogens are present? 2 hydrogen in each molecule. So in that case, you have to multiply by 2. Is it not so? This one, that is 2.408 into 10 power 25. What atoms? Hydrogen atoms. Got it? Right? Then, fifth one. I have totally asked number of atoms of hydrogen and oxygen. That you have got 2 hydrogen and 1 oxygen in each molecule. So it means you have to multiply by 3. So what is our answer? 3.612 into 10 power 25 what? That is number of atoms. That's all. Atoms of, you can say, hydrogen and oxygen, right? In 360 ml H2O or 360 gram H2. Got it? Why these two are equal? Because the specificity is 1. Okay? Right. I hope now this point is very, very clear to you. Okay? Any doubt? So I will try to give you some worksheet, try to work out. Okay? Later. Okay? Right.